Hello everyone, welcome back to this online class. Today we are going to look at Hermite interpolation. Now we have this question. We are given the following table for the values of f of x and f prime of x, as you can see. Now we are asked to estimate the value of f of negative 0.5 and f of 0.5 using Hermite interpolation. So from our table, this value is x naught. This is x1, this is x2. F of x values here will have x, f naught, f1, f2. Similarly, the values of f prime of x, here we have f naught prime, f1 prime, f2 prime. You see here, when you talk of Hermite interpolation, there are two conditions to be satisfied. We need an interpolating polynomial that will fit the data for f of x and also f prime of x. So it's like we have 2 into n plus 1 conditions or simply constants that we need in our interpolating polynomial. So then it means that our polynomial must be of degree at most 2n plus 1. That's the degree of the polynomial, at most 2n plus 1. Now when you look at our table, n is equals to 2. From this table, n is equals to 2. So therefore, what is the interpolating polynomial for this kind of data? So let me give you the general case that the polynomial p of x, let me talk of pn, 2n plus 1 of x is equals to the sum from I is equals to 0 to n, ai of x, fi, plus the sum from I is equals to 0 to n of bi of x, fi prime. So this is the Hermite interpolation polynomial of degree at most 2n plus 1. Now, what is ai of x and bi of x? You can just say that where what we call ai of x is defined by 1 minus 2 into x minus xi times li prime of xi, then times li squared of x. And then the other one, bi of x, is defined by x minus xi times li squared of x. So the li is the Lagrange coefficient, which I'll tell you how to compute. Now, look at our interpolating polynomial. Now, for the data that is given, our n is 2. So I want to expand this polynomial when n is 2. So you write put n is equals to 2. Let me call this equation star. Put n is equals to 2 in star to get, when you substitute n is 2, this is what you're going to get. So we'll now be talking of p. Remember now 2 times 2, that's 4 plus 1, that's 5. So the degree of the interpolating polynomial must be at most 5. So that will equal to a naught of x, f naught plus a1 of x, f1 plus a2 of x, f2. Then the other summation is plus b naught of x f naught prime plus b1 of x f1 prime plus b2 of x f2 prime. Now, you know how to find the ai of x and also bi of x. In this case, I ranges from 0, 1, and then the last one is 2. So you can just say from I is equals to 0, 1, all the way up to n, even in the other one, bi of x. So what is important is knowing this formula for the Hermite interpolation. Now let's compute the Lagrange coefficients and also the ai of x and bi of x. So we start by finding the Lagrange coefficients. So right here, Lagrange coefficients. Let's start with L naught. L naught of x is the same as x minus x1, x minus x2 over x naught minus x1, x naught minus x2. And so you can refer to your table. We have the values of x naught, x1, x2. We can read them from the table. X naught is -1, x1 is 0, and x2 is 1. So let's substitute those values. So this will give us x minus 0, x minus 1 over x naught, that was -1 minus 0, -1 minus 1. And so that should be able to give us 1 over 2 into x squared minus x. Let's also get L1 of x. L1 of x is equals to x minus x naught, x minus x2 over x1 minus x naught, x1 minus x2. So again, if you replace the values from the table, we'll have x minus -1, so that's x plus 1, then x minus 1, everything over x1 is now 0, so 0 plus 1, 0 minus 1. And so the result here is negative x squared plus 1. Similarly, L2 of x is equals to x minus x naught, x minus x1, everything over x2 minus x naught, x2 minus x1. So let's replace again those values from our table. We'll have x minus -1, so that's x plus 1, x minus 0. Our x2 is 1, so 1 plus 1 into 1 minus 0. When you press that, when you work it out, you get 1 over 2 times x squared plus x. So look at our definition of the other coefficients, that is ai of x and bi of x. Those are called Hermite coefficients. We need to know the derivative of li of xi, and also we need to square the li of x. So because I'll need the derivatives of these Lagrange coefficients, let me work them out here. So you can write here that L naught prime of x, when you differentiate, you're going to get 1 over 2 times 2x minus 1. 1 over 2 into 2x minus 1. Also the other one, L1 prime of x. That's negative 2x. And L2 prime of x, it should give us 1 over 2 into 2x plus 1. So having found those derivatives, let's now compute the Hermite coefficients. So now talk of Hermite coefficients. We start with those of AI. Remember, I is 0, 1, and all the way up to 2. So we'll start with A0. A0 of x, look at the way it is defined. We'll have 1 minus 2, 1 minus 2 into x minus x0 times L0 prime of x0. Then what you get, you multiply by L0 squared of x. Let's substitute. This is the same as 1 minus 2 into x plus 1. Remember, x0 is negative 1. L0 prime of x0. Our x0 is negative 1. So what I'll do, I'll go back here. Where there is x, I'm going to put negative 1, so that here you get L0 prime of negative 1, which is our x0. What will we get here? It will be 1 over 2 times 2 into negative 1 minus 1. And so this should give you negative 2 minus 1, that's negative 3. So the answer is negative 3 over 2. So that's what I'm going to write here. So the result here is negative 3 over 2. Then now L0 of x, you square it. What is our L0 of x? It is this one. So this is the value that I'm going to square. When I square that, I'm going to get 1 over 4 into x squared minus x, and then you square it. So let's expand this. The first bracket will give us, because you can see here, 2 and 2 will cancel, and even the negative will cancel, that I have 3 into x plus 1, then plus another 1. That will be 3x plus 3 plus 1, which is 3x plus 4. So this will give us 3x plus 4 times 1 over 4 into, when we square this, we get x raised to 4 minus 2x cubed plus x squared. And so you can combine those two brackets. Let's simplify that completely. When you work it out, because I know you can do it, you need to get 1 over 4 outside. Then inside, we should get 3x raised to 5 minus 2x raised to 4 minus 5x cubed plus 4x squared. So that's our A0 of x. Do the same to find A1 of x and A2 of x. So similarly, our A1 of x from the definition is given by 1 minus 2 x minus x1 L1 prime of x1 L1 squared of x. So let me replace the x values and even the Lagrange coefficients. So this should give us 1 minus 2 into x. Our x1 is 0. Then now we need L1 of x1, L1 prime, I mean, of x1. Remember, our x1 is 0, so I'll go back here and write L1 prime of x1, that is 0. When I substitute 0, I'll get -2 times 0, which will give us 0. So the result there is 0. So this is times 0. Then L1 of x, you square it. Let's check our L1 of x. Is this one here. I want to square it. So that's -x plus 1 squared. -x squared plus 1, then you square everything. So here we'll have -x squared plus 1, everything squared. And so this can be written as, now the first bracket is just 1. Because this is 0, so this will vanish. So remain with the 1 times the whole of this one. It is 1 times 1 minus x squared, everything squared. When you work it out, this is what you need to get. You need to get x raised to 4 minus 2x squared plus 1. Then finally, we need to compute a2 of x. Again, from the definition, a2 of x is given by 1 minus 2 into x minus x2 times L2 prime of x2, then times L2 squared. Of course, it was a function of x. Again, let's substitute the x values. We are going to get 1 minus 2 x minus 1. Remember, x2 is 1. Now I need L2 prime of x2. Let's go back to where we have the derivatives. Now I need L2 prime of x2. What is our x2? Was 1. So when x is 1, we are going to get 1 over 2 into 2 times 1 plus 1. And so that should be able to give us 3 over 2. So that's what I'll substitute in place of L2 prime of x2. So I'll substitute it here. We have found 3 over 2. Then now L2 of x is squared. Let's see, our L2 of x is this one. This is what I want to square. When I square it, I'm going to get 1 over 4 times x squared plus x, everything squared. So that would be 1 over 4 times x squared plus x, and this is supposed to be squared. And so you can proceed to simplify this further. The 2 will cancel with this. I expect to have 1 minus 3 into x minus 1, which will give us 1 minus 3x plus 3. That is 4 minus 3x times 1 over 4 into, when you square this, you need to get x raised to 4 plus 2x cubed plus x squared. Again, expand that completely. I'll open the bracket. When you work it out, you need to get 1 over 4 times -3 x raised to 5 minus 2x raised to 4 plus 5x cubed plus 4x squared. Now we are through with the a subscript I as a function of x. Let's compute the other coefficients, that is b subscript I as a function of x. Look at the definition. We only need to replace I. Remember, I ranges from 0, 1 all the way up to n. And in this case, our n is 2. So you can write similarly. Let me write it here. We start with b naught of x. From that definition, it is the same as x minus x naught, L naught of x you squared. So this will give us our x naught is -1, so that will be x plus 1. Now, L naught of x squared, remember our L naught of x was 1 over 2 times x squared minus x. We need to square that to get 1 over 4 into x squared minus x. Then you square this. Let me expand. When you expand, you're going to get, of course, 1 over 4 x plus 1 into x raised to 4 minus 2x cubed plus x squared. Open the bracket completely so that you get 1 over 4 outside. Then inside we'll have x raised to 5 minus x raised to 4 minus x cubed plus x squared. So that's b naught. Let us find b1 of x. Again, from the definition, b1 of x is equals to x minus x1 times L1 of x, and the whole of this should be squared. Let's substitute. This should give us x minus 0. Remember, x1 was 0. L1, what was our L1? It was negative x squared plus 1. We need to square that. So negative x squared plus 1, the whole of this is squared. When you work it out, we'll get x into x raised to 4 minus 2x squared plus 1. And so if I open the bracket completely, I should be able to get x raised to 5 minus 2x cubed plus x. And finally, let's compute b2 of x. Again, from the definition, b2 of x is equals to x minus x2 times L2 of x. This is supposed to be squared. If you make the substitutions, this will give us x minus 1. Our L2 of x was 1 over 2 into x squared plus x. Now that's what we need to square to get 1 over 4 x squared plus x, and this is supposed to be squared. If you work it out, you need to get 1 over 4 x minus 1 x raised to 4 plus 2x cubed plus x squared. And so open the bracket completely to get 1 over 4 outside. Inside we have x raised to 5 plus x raised to 4 minus x cubed minus x squared. So having found the Lagrange coefficients and the Hermite coefficients, let's now substitute them back to our interpolating polynomial. So let me take you back. This was the polynomial. We said the polynomial must be of degree at most 5. So we are going to substitute them here. Of course, I'm going to call this equation star star so that we just replace the functions that we have found. So you can just say hence equation star star becomes, and let's substitute. This is what you're going to get. Right here, hence equation star star becomes P5 of x is equals to, let's start with A naught of x, then times F naught. So we substitute our A naught, what we got 1 over 4 outside. It was 1 over 4. Let me use another color. I can just return red. 1 over 4 into 3x raised to 5 minus 2x raised to 4 minus 5x cubed plus 4x squared. We multiply this by F naught. When you go back to our table, of course, you can see from the table, our F naught, let me just take you back so that we read it together. Our F naught is 1, F1 is 1, and F2 is 3. Also, we will need F naught prime, that's negative 5. F1 prime will be 1, and F2 prime will be 7. So we go back and substitute the value of F naught here. So I take you back here. Our F naught is 1, so right here 1, plus the next is A1 of x times F1. Our A1 of x was x raised to 4 minus 2x squared plus 1. This should multiply 1, which is our F1. Then we also have A2 of x times F2. So our F2 of x was 1 over 4 into negative 3x raised to 5 minus 2x raised to 4 plus 5x cubed plus 4x squared. Now, what is our F2? That should multiply F2, which is 3. So this is times 3. Then there was also plus B naught. Our B naught, we have found 1 over 4 times x raised to 5 minus x raised to 4 minus x cubed plus x squared times F naught prime, that was negative 5, plus now B1 was x raised to 5 minus 2x cubed plus x. F1 prime is 1 from our table. And lastly, we have B2, which is 1 over 4 times x raised to 5 plus x raised to 4 minus x cubed minus x squared. And this times F2 prime, which is 7. So when you simplify what we have here, or simply collect the like terms, this is what you need to get as you're interpolating polynomial. It should give you 2x raised to 4 minus x squared plus x plus 1. I believe you know how to simplify. That's what you need to get. So you see, these are polynomial of degree 4. We said the degree of the interpolating polynomial for this case is of degree at most 2n plus 1. And because n was 2, we expected our degree to be at most 5. And it is clear that the degree of the polynomial is 4, which is less than 5, less or equal to 5. So now that we have found the interpolating polynomial, let's now see how to use it to approximate f of negative 0.5 and f of 0.5. So you can just say, therefore, let's start with the f of negative 0.5 is approximately equal to p5 of negative 0.5. So we are just substituting the values of x. Where there is x, we replace that by negative 0.5. So that will be 2 negative 0.5 raised to 4 minus negative 0.5 squared plus negative 0.5 plus 1. And so that should be equal to, when you press it in your calculator, you need to get 3 over 8. Similarly, f of 0.5 is approximately equal to p5 of 0.5. And so when you press again this in your calculator, let's replace. That is 2 into 0.5 raised to 4 minus 0.5 squared plus 0.5 plus 1. And again, press this in your calculator. You need to get 11 over 8. So thank you all for watching this video. Please subscribe to my YouTube channel. That is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving Hermite interpolation. Bye-bye.